Hi there, Mrs McTaggart here. In this video we're going to be looking at higher optimisation questions. Now I've got a repeat higher class this year, and not to put you off, but the minute I talk about optimisation questions they're like, oh no, I hate these. But you know what, they are not that bad. I admit they have two parts to them. Part A is always a bit tricky. Part A is a show that. Now to me a show that means you can get guaranteed marks, because if you can't get it, you know you've got it wrong, and if you do get it, then right, you've got it right. Right, so it's a show that part, which means that leads into part B. However, if you can't do part A, it's not the end of the world, because most of the marks are in the part B. And the part B, you just continue with what they gave you as the show that. So you're going to use what they gave you as your show that as your starting equation. And we have these at National 5 as well. And again, we try and train you that the part A, if you can't do it, that's fine, give up. But you can do the part B, because the part B is literally your stationary point question. Get stationary points, get your nature table. And then there's a wee one mark conclusion at the end. So I'm going to show you a couple of kind of common questions. A lot of the times I think the problem is because it relies on previous knowledge. It relies on things like surface area of a shape, volume of a shape that we maybe haven't done for a good few years. So let's have a look. I've got several examples. Right, here's my first one. We are told a rectangle has length L and breadth B. So I've drawn a little sketch, so I'm just going to put that on there. So I'm going to call this L and B. Its perimeter is 80 and its area is A. We have to prove that A equals B bracket 40 minus B. Now you could look at that and think, what on earth is that on about, right? Prove what is that? We have to prove something to do with the area. So why don't we start with first year maths knowledge, not even first year primary school maths knowledge. Area of a rectangle is L times B, right? So area of a rectangle is LB. Now let's look at what else they told us. They also told us something about the perimeter. They said the perimeter is 80. Now the perimeter of a rectangle is length plus breadth plus the other length plus the other breadth. So we basically have 2L plus 2B. So perimeter equals 2L plus 2B. And we actually know that's 80. So I'm just going to rewrite that as 2L plus 2B equals 80. Okay. Now if we look at their original, go back to the prove that bit. If you look at this now, we have A equals B times something. Now you might notice that the L has disappeared. So we need to do something to get rid of that L in the area formula. So I'm going to rearrange my perimeter formula now to get L on its own. So 2L equals 80 minus 2B. And then I'm going to divide everything by 2. Both of them divide by 2, so I'll do it individually, which leaves you 40 minus B. Can you see where the 40 minus B's come from now? So now we know what L is. We are going to replace that L there with 40 minus B. So A equals B bracket 40 minus B. So I've done the show that. So I'm sitting there going, yeah, you've got it. I've got my first 2 or 3 marks for using first year maths knowledge. Part B though follows on from that. So even if you can't get A, let's say you took a complete blank, oh I don't know what to do, we can do part B. It's talking about maximum area. It's talking about maximising something. So we should be recognising this. This is a stationary point question. So for part B, we start with their formula for area, but we're going to expand it out and we're going to make that 40B minus B squared. Now, we need to find the value of B that maximises that. So we're looking for our maximum turning point. So we're looking for our stationary points. So we differentiate. So we're going to call this A dashed, which gives us 40 minus 2B. Now remember the little statement for stationary points or stationary values, we're going to set A dashed equal to 0. So if you put this equal to 0, you end up with 40 equals 2B. Let's create a wee bit more space. And that, of course, would give you 20 equals B, so B equals 20. Right, I'm going to go check the nature for B and check that that does, in fact, maximise it. So I'm going to draw a nature table. So I'm going to have X, oh, it's not X, sorry, it's B in this case, force of habit. So we're going to have B, anything up to 20 and anything beyond 20. And then here we'll have A dashed, and then we'll have our shape. So at 20, we know that that gives us 0, our gradient is 0. So we're going to pick a number before 20 and we're going to sub it into our A dash. So we're going to sub it into this line here. So simple number to choose, you could choose 19, or why not go simple and just use like the number 1, as long as it's lower than 20, or even 10 if you wanted. So lower than 20, let's do 10, that would be 40. Take away 2 times 10, well that's 20, which is positive. After 20, let's just go with 30, so I'm using 10 and 30 here. So afterwards, the number 30 would be 40, take away 2 times 30, which is 60, so that's negative. So I end up with a maximum turning point. Now the question had said, find the value of B which maximises, let me just check the word in, find the value of B which maximises the area and hence the corresponding dimensions. So B equals 20 maximises, so that's the first thing I'm going to write. So I'm going to write B equals 20 maximises area. That's not right, oh my goodness. Maximises the area. And then it wanted the corresponding dimensions. So if my breadth is 20, remember we had that 2L plus 2B equaled 80 for our perimeter. So that makes a little equation for us to go solve. So we have, we know our breadth was 20, so we've got 2L plus 40 equals 80. So 2L must be 40, so L would also be 20. So lo and behold, it's actually a square. So our length equals 20 and our breadth equals 20 as well. That would be our dimensions. Okay, let's try another one. So this one here, we have an open cuboid, basically it's a box with no lid. It's an inner surface area of 12 square units. We have to show that the volume of this cuboid is given by this expression, and then we have to find the exact value of x for which this volume is a maximum. So it's very similar to the last question. We're taking in some of our basic geometry knowledge, and then we have to work out a value that gives us the biggest volume possible. So let's start simple. Volume of a box. Volume of a box is LBH. Now our length is 2x, our breadth is x, and our height is h. So if I tidy that up, we have 2x squared h. And I think everyone should be able to do that bit. Okay, the other bit of information they give us is the surface area. Now, the surface area of this box, if you think about it, the front would be 2x times h. So I'm just going to draw on this. That would be 2xh. The side would be x times h. And the base, although we can't see it, the base would be 2x times x, which would be 2x squared. So our surface area would be the front and the back match. So you've got 2xh doubled. So you've got 4xh plus the two sides match. So you've got xh plus another xh. So we've got 2xh. And then your base, which is 2x squared. And that can tidy up to 6xh plus 2x squared. Now I'm going to go back and look at my original formula. So my original formula has got 2/3 x, 6 minus x squared. Notice there's no h in there, right? So we're going to have to go do something to get h on its own, right? So I'm going to rearrange this equation here. Now there's something else I haven't put in. They told us that the surface area was 12, so I can put a 12 in here. Now I'm going to change the subject of this to get h on its own. So I've got 12 minus 2x squared equals 6xh. And then I'm going to divide by 6x. So I have 12 minus 2x squared, and I'm going to divide each thing by 6x. And that will give me my value for h. Now 12 divided by 6 is 2. So I've got 2 over x for my first term. 2 over 6 is a third, so I've got 1 over 3. And then x squared divided by x would just give me x. So I've really got x over 3 equals h. So what I have to do now is substitute that in for h. So I have v equals 2x squared times 2 over x minus x over 3. And if I tidy this up, Then the 2x squared times 2 gives me 4x. X squared and the x will cancel down to 4x. On the second term, I will have a 2x cubed all over 3. Now that still doesn't look quite like what they've got. However, I can get it to that. They've taken out a common factor of 2/3 x, so I'm going to do the same. So let's take out a common factor of 2/3 here. So 2/3, they both definitely have an x in common. So if I take out a common factor of 2/3 x, right, 4 divided by 2/3 is the same as 4 times 3 over 2. 4 times 3 over 2 is 12 over 2, which is just 6. So that gives you 6. Now it's not something we would usually do, is take out a common factor like that. So that leaves us with 6. Take away 2/3 divided by 2/3 is just 1. And then the x cubed becomes an x squared. Look, I've got it. I've got to show that. But do you know what? I reckon if you can get down to this line here, you've nearly got most of the marks. There's only 1 mark for all that other wee proof bit that I've done. However, we have done this bit, right? We have got our show that. In the exam though, you can take a complete blank, but I would like to think everyone would be able to write down the volume of a cuboid and maybe the surface area of the cuboid and get something. But if you couldn't, part B, we're going to take that equation and we're going to move on from there. So I'm going to take a new screen and start part B. So what I've done here is I've taken what I had got V down to before I took out the common factor to do the show that bit. So we need to find the value of x which maximises the volume. It hasn't asked what the volume is, but it very easily could do for an extra wee mark. So we need to go do our stationary point. So we're going to find V dashed. And the reason I took this form instead of the form where it was 2/3 x bracket 6 minus x squared is purely because I need to multiply it back out anyway. So I've taken it from this line. Right, let's differentiate. So 4x just becomes 4. 2/3 times 3, well the times 3 and the divide by 3 cancel out. So that's just negative 2x squared. And remember, we're looking for our stationary point here. We're looking for a maximum actually. So we're going to set v dashed equal to 0. So we have 4 minus 2x squared equals 0. I always take my letters over to keep them positive. So I'm going to divide by 2. 4 divided by 2 is 2. So 2 equals x squared. Oh, so x equals plus or minus root 2. Now, wait a minute, we're talking about lengths. So actually, x equals root 2 in this case. Now, what I'm going to do is I'm going to do my nature table now. So I'm going to do x, anything up to root 2 and anything after root 2. V dashed and my shape. So let's have a look. So if I pick a number less than root 2, well root 2 is like 1 point something, so I'm going to choose 1, right? If I plug in the number 1 to my equation, so back to my V dashed line, so I'm subbing into this here. If I plug in the number 1 here, then I have 4 take away 2 times 1, so that's positive. I'm going to pick a number bigger than that, so I'm just going to go with 2. Right, well 2 squared is 4. 4 times 2 is 8. 4 take away 8 is negative. So I have a maximum. So in conclusion, it says maximum volume occurs when x equals root 2. And that's that question done. Okay, so I thought I'd put in another wee one. There's no harm in me doing quite a few of these just to get you into the habit of looking at them. So the part A is the most difficult bit. I think you'd agree that the other bits are not too bad. So this one, the council is creating 6 fenced allotments as shown. So these are all little allotments, these little rectangles. The area of the land is 108 metres squared. We have to show that the total length of fencing is given by this formula here. So the length of fencing is all my black lines. So technically what I have here is all these little bits are x and all these little bits are y. So my total length of fencing, well let's start with the area of the land, right? So the area is length times breadth. My length is 2y and my breadth is 3x. So my area is 6xy, okay? Then let's look at the total length of fencing. So the length, oh sorry, I should have put in, I knew that the area was 108. So I can actually divide that by 6. 108 divided by 6 is 18. 6 into 10 is 1, remainder 4. Yes, so that's 18 equals xy. So I've taken that down a wee bit. Right, the length in this case, so the total length would be, right, if I count all up my y's, I have got 1, 2, 3, 4, 5, 6, 7, 8y. And if I count all my x's, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. Obviously, there was different ways of doing that, but there's what I've got for my length. Oh, there's a 9x, so this is looking good. If I then look at my formula, I notice my formula has got no y's, so I need to do something with the y's. So in the area formula, I can rewrite y as 18 over x. Now, just getting there has got me my first mark. So I'm going to replace y with 18 over x. So I have 8 times 18 over x plus 9x. So now I need to do 8 times 18, just to double check. It should be 144, I'll double check it. 8 8s are 64. So 8 8s are 64, 8 1s are 8, it's 144. So this gives me 144 over x plus 9x. Now that is my proof. I have the same thing as up here. It's just back to front. So that's okay, I've done my show that bit. Right, now I have to find the value of x that minimises the length of fence this time. So I'm going to do my nature table, and my nature table should come out with a minimum this time, hopefully. So let's take the part A. So part A, I'm going to take it in their order though. So they wrote, sorry, not L dashed, they wrote that L of x equals 9x plus 144. Now the over x I'm going to bring up and make that -1. So they gave us that. So even if you couldn't do all that bit for part A, you start with that for part B. First thing you do is you differentiate. So we're going to differentiate it. 9x goes to 9, negative 144x to the power -2. Now I know I'm going to do some subbing in and things in a minute and rearranging, so I'm going to rewrite this positively as that. And remember, for my stationary points, I can set L dashed x equal to 0. I'm going to shove a 0 in there. I'm going to bring the fraction over and make it positive. And that leaves me with that. I'm going to have to do some cross multiplication because that x squared should be up on the top. So that would give me 144 equals 9x squared. So I'm going to do 144 divided by 9. I'm going to do a little sum, so that gives me 9 to 14 is 1, remainder 5, so it gives me 16. Oh, that's good because I can square root 16. Always good to know. If it wasn't 16, then I'd be worried, because if I can't square root it, I'm going to have hideous values for x. Now remember, when you take the square root of 16, you get two answers. You get plus and minus 4. But since we're talking about length, we can eliminate the -4 one, so it's just actually 4. Okay, so x is 4. We're going to check this in the nature table. Remember, we're looking for a minimum. So I'm hoping a minimum turning point comes out here. So L dashed x in here and shape. Right, where am I subbing into? So let's highlight what I'm using to sub into. I'm going to sub into this bit here where it's written nice and positively. So let's pick a number less than 4. Oh, let's just go easy. Let's go with 1. And a number bigger than 4, let's go with 10. So a number less than 4, we've said 1. So that would just be 9 take away 144 over 1. So 9 take 144 is definitely negative. I think you'd be able to see that